How do you determine sigma itself? Well, the calculations are that simple equation. You have to define the total allowable error, you have to estimate the bias, you have to estimate the SD or CV. You have to use either all of these in percentage units or concentration units. Now, I'm going to give you, a rationale for the sigma calculation. What bias takes into account is this distribution shifting around? And if it shifts, that uses up some of the available space, some of the allowable error. And then the SD determines the width of that distribution. So the two of them have to be taken into account in the calculation of sigma. Here's an example. Hemoglobin A1C. College of American Pathologists define total allowable error as 7%. So we've got a TEA, 7%, a bias of 2%, a CV of 1%. What's sigma? This is not a trick question. So 7 minus 2 is 5 divided by 1 is 5. Okay. What if we had a bias of 1% and a CV of 1.5%? What's sigma? What? I know that the drinks they handed out did not have alcohol in them. There's no excuse for this, folks. What is 7 minus 1 is divided by 1.5 is 4. Okay, there's only one answer. There's not a range of answers. Not, 3 doesn't count and 5 doesn't count. It's 4. And then what do we have if we have a bias of 2% and a CV of 2%? 7 minus 2, 5. 5 divided by 2 is 2.5. That's a tough one, I know. The fraction thing. Well, those three methods would take entirely different types of quality control. The first one, with the sigma of 5, is easy to do with an n of 2. The middle one is going to take an n of 4. And the bottom one, you can't run enough QC. You can't afford to run enough QC to be using that method in your laboratory. Now, how can we figure that out? Well, there are a couple different tools that are available. The CLSI C24 document, the current version, so that's the document that's in revision that Kurt is working on. That has a tool for selecting control procedures based on sigma. And then there is a related tool that we call a chart of operating specifications. And I'm going to show you both of those. So this is the sigma QC selection tool. And the way this works, so these are those same kinds of power curves that Kurt talked about. So you calculate sigma. So here's our method with sigma 4. You remember where 4 came from. You did that calculation. And then you look to see, what control procedures will give you a probability of 0.9 or 90% chance of detecting the critical systematic error. And sigma is related, so sigma is on the top scale, and the bottom scale is the size of the error, the critical systematic error. And those two parameters are related, so you can use either metric. It's simplest to use sigma. So for this particular method with a sigma of 4, you should be using a multi-rule with an n of 4, or if you want to use a single rule, 2.5s with an n of 4. So again, rule of thumb, you get a sigma of 4, you should be running 4 control measurements.